Sample problem 14.07, Bernoulli principle for leak water tank. In the Old West, this part of the fires a bullet into the open water tank, as you can see in this figure. Now that create a hole distance h below the water surface. Then what is the speed v of the water exit the tank? So you got to apply the same kind of approach to solve this problem, like 14.02. So here, volume flow rate, V is the A times the volume ratio V, so that is A times V naught. So here the V naught is A or two areas. It's like A is the whole of the bullet, and this area is the area of whole surface. So that should be multiplied by the speed of the water out of the hole. So here, A, as you can see, is much smaller than total surface of the water tank, and the velocity V naught of the water itself is much smaller than the speed of water leaving the water tank. So if you plug that number and apply to Bernoulli's equation on principle, then that equation, which is 1/2 P naught plus 1/2 low B naught squared plus low G H equals P naught pressure, the reference pressure of the water tank, plus 1/2 low V squared plus low G times equals 0. Times as 0 actually. So there's, because that is y equals 0 is the reference point, so that can cancel the potential energy term out of this formula, Bernoulli equation. So you have to just stay with this Bernoulli equation and modify it with this existing condition. So now, as I said, this velocity of water tank is much smaller than the velocity of the water out of this hole. So the V naught is much smaller than V applied. Then this term. So 1/2 low V naught squared is much smaller than 1/2 low V squared. So you can ignore this term out of it. Then you can simplify the equation with this form. So basically that you just do not have this first, because basic pressure of water tank is equally applied to both sides of the equation. So velocity V out of this water tank is square root of 2G H, the proportional to the height, square root of the height of water tank. So the height, the more water contained inside this water tank, the water flows out of this volumetric water flow out of this hole is faster. So pretty much it's determined by or dictated by height of the water inside the water tank. So speed of the water coming off from this hole is proportional to the square root of 2GH approximately. So that, as I said, the more water inside the water tank, the more speed, the speed of water coming off from this tank is higher.